respiration. We have cellular respiration, aerobic cellular respiration, and it happens when we have some O2 and some C6H12O6, and this then converts into some CO2 and some water, and we also get some energy in the form of ATP. We have 4 steps in this aerobic cellular respiration. We have glycolysis, where we have the glycose, the C6H12O6, which is converted into pyruvate. Then this pyruvate in the link reaction combines with what is called coenzyme acetyl coenzyme A, and this then goes further into the Krebs cycle, where the coenzyme is gone and it covers up with some other carbon molecules, and this then becomes citrate, and we then have some NADH and FADH, which goes out of the Krebs cycle, and these then goes on to the electron transport chain. In this chain we have the hydrogen, which is removed from the FAD and NAD, and then these convert into more energy. So now we have 4 steps of glycolysis. We have phosphorylation, and we have lysis, oxidation, and ATP formation. So now we have glucose, which from the use of 2 ATP in the phosphorylation step becomes to first by 1 ATP becomes a phosphorylated 6-carbon sugar, which is the fructose biphosphate, and then another one is added, and then right after the second one has been added, we go to the lysis step, which is the splitting of the 6-carbon sugar, and it becomes 2 times 3-carbon sugars phosphate, also known as 2 times triose phosphate. Then we have the oxidation step, where we have 2 NAD+, which goes in 2 inorganic, is added. 2 inorganic phosphates are added, which later on, as we can see, will create some ATP. And what is left, what leaves this equation is 2 times NADH plus and H plus. Then we go on to the ATP synthesis, where we have the inorganic phosphates adding, and this results in the creation of 4 ATPs. And in the end result, we have 2 pyruvates. And if we look to the other figure to the right, then you can see we have the glucose, which is a 6C molecule. Then we have the addition of 1 inorganic phosphate, and it becomes a fructose biphosphate. Then we have the addition of another inorganic phosphate, and it becomes what is afterwards splitting into the 2 triose phosphates. Then we have the addition of an inorganic phosphate to each of these, and first where one of these inorganic phosphates are then removed to create 2 ATP, and then afterwards they are removed again to create another 2 ATPs, giving 2 pyruvates. The previous step of glycolysis happened in the cytoplasm. Now we are inside the mitochondria, and we have the link reaction. The link reaction is where we have our pyruvate, a 3-carbon, which by the addition of an NAD plus and the coenzyme A ends up excluding a CO2 molecule, and we have also the exclusion of NADH and plus and H plus. Then this leads to the acetyl coenzyme A, which is a 2-carbon. And this 2-carbon can join up with the 4-carbon acid, which is known as oxaloacetate. These two then combine to form the citrate, which is a 6-carbon, and this all happens in the Krebs cycle, which means that we have now left the link reaction, and as such it also means that the coenzyme A is leaving our cycle. At the citrate, we have, after the citrate has been formed, we have a CO2 which once again leaves the cycle. We have some NAD+, which takes out some H ions, meaning that they create some NADH and H+. This leads to a 5-carbon acid known as ketoglycerate. And after the ketoglycerate has been formed, we have another CO2 which is being excluded. This also creates an ATP. And then we have, in some steps, 2 NAD plus and 1 FAD plus, which enters the cycle and then leaves the cycle as 2 NADH plus 2 H plus and 1 FADH and 1 H plus. So in total 3 H plus, 2 NADH and 1 FADH. Then we're back at the 4-carbon acid, which is the oxaloacetate, which can again join up with the acetyl coenzyme A for the Krebs cycle. This cycle is also known as the citric acid cycle, and it is still going on in the mitochondria. The last step, which is the electron transport system, is something which has happened in all of our different reactions, where the oxidation has caused hydrogen to be removed in both the glycolysis and the Krebs cycle, and the hydrogen is also converted to some water. This is also how the bulk of the ATP is created. And now we can count a bit, so to speak. We have the glycolysis, which leaves us with 0 CO2. However, the glycolysis leaves us with 2 ATP, 2 net ATP. It leaves us with 2 reduced NAD. And then it leaves us with 0 reduced FAD. The link reaction, which was the pyruvate to the acetyl coenzyme A, gave us 2 CO2, 0 ATP, 2 reduced NAD, and 0 reduced FAD. And the reason that it gave us 2 is because, as you can see on the Krebs cycle and the link reaction, we have only shown this happening once, but we have 2 pyruvates, which enters this as with 1 glycolysis. 1 glycose gave 2 pyruvates. For the Krebs cycle, we have 4 CO2. We have 2 ATP. We have 6 reduced NAD. And we have 2 reduced FAD. And that leaves total 6 CO2, 4 ATP, 10 reduced NAD. Oh, apparently, did I say 0 up in the glycolysis? Oh, we had 2 up in the glycolysis. Fancy. So yeah, 10 reduced NAD and 2 reduced FAD. And as we know that we will be having a total of 38 ATP. From this, we so far have 4. We know that the reduced FAD creates 2 per 1 reduced FAD, 2 ATP per 1 reduced FAD in the electron transport, which gives us 4 ATP from that, and the reduced NAD gives us 3 per 1, so that gives
which is 30.